Hello, my name is Cloutier, and this is my student innovation project, solar trees. Current arrangements of solar panels involve connecting them side by side and in row upon row upon row, usually in large fields. These two images are of solar farms, and they use a large amount of space. The downside is that the ground space, the red in this diagram, is completely unusable for anything other than harnessing the sun's energy. That's a lot of space to be rendered unusable for anything else. My proposed arrangement frees up some of that space. Trees have leaves, which are nature's own solar panels. The trunk of the tree is the only thing sticking in the ground, making any space unusable, so the amount is greatly reduced of unusable ground space. The tiered branches make sure that no panel is blocked out by another one. To build the prototype, I needed to collect all the materials. The solar cells, as well as a voltmeter, soldering iron, solder, some other tools to bend wire, hangers that are not pictured, and a dowel rod for the trunk of the tree. Here is a picture of the finished product for the traditional method, and a finished product for the tree method. Now that we have both arrangements complete, we just need to make sure that they're producing electricity. In other words, that the wiring is working. To do that, we just need our voltage meter, and since we're indoors, it will be less voltage than it will be outdoors under the sunlight. After we have the voltage, we can calculate the area that each method takes up, and that's the ground space used. For the traditional arrangement, I will only be taking the area of one cell and multiplying it by the 10 that are on here, because there are gaps in my little model, but in real-world application, solar panels are laid side by side, and there are no gaps. For the tree arrangement, the area all we need is the radius of the dowel rod, since this is the only amount that's going to be only amount of ground space that's going to need to be taken up by the tree design, as it sits like this in the ground. Now we can measure both. We are already up to a good start. Alright. We'll measure the traditional arrangement first. If we get something, we know our wiring is good. Looks like almost 10. Alright. Now I'm going to measure the tree arrangement. Almost 13. Okay, so our wiring is good. We can take them outside and get a final reading under the sun. I placed both arrangements outside at about 11:30 in the morning on a clear day, making sure neither one could impede the other's exposure to the sun. The traditional arrangement I thought was losing some current through contact with the ground, so I raised it up onto a table, and you can see that they're angled at about 24 to 25 degrees. The traditional arrangement yielded about 37.58 volts, while the tree method yielded 38.73. All that was left was the area. The solar cells, for the traditional, I just needed the width and the height, and I would multiply that by 10. And I needed the radius for the dowel rod for the area of a circle. The ground space by the traditional method was 18.8672 square inches, while the tree was only 0.785398 square inches. Plugging all of this information in, we get our voltage per square inch. Traditional method producing 1.99182 volts per square inch, while the tree method produced 49.2998 volts per square inch, which meant that the tree method used 24 times less space and produced the same amount of volts, making it 24 times more efficient. And that's my video. Thank you for watching.